Hi, this is my MIS 665 Data Analytics final project. So at the top, I just have my name, K-State honor code. I left a cell, and that's where I'll be posting the link to this video. Then I go ahead and I import everything I think I could possibly need for this analysis. Might not be everything right off the bat, but I could just import later if I need something else. So I go ahead and just read my data. I look at the head just to make sure I read it incorrectly. I got 5 rows, 48 columns, so it looks good. So I go ahead and describe my numerical columns, and that's why I end up with 33 here and not 48, because not all of them are numerical. First thing I see is it is definitely big data. There's a lot of entries, lots of really big numbers. So good thing to just do a simple describe and look at things like that. So then I go to check my data types. See, I'm working with pretty much ints, floats, and then objects. And interesting, I see the accepted date is an object, and usually it's nice to have dates as a date time object for time series analysis, excuse me. So I go here and I switch it to a date time data type and then set it as the index for my data frame. And it was all happy doing that, so now I have it as a date time and as my index. So then I check for null values just to clean up the data some and see that there are some columns with very excessive null values, and I originally tried to drop them entirely, but it was causing issues with other parts of the data. I'm not sure why. So I ended up just filling them with a value that doesn't matter, so 0. So then I just check again, make sure that they all got filled. So now anywhere there was a null value, it just has a 0 as a placeholder. So then I do a simple box plot to check for outliers. And there are certainly outliers you can see, but you can't really read where, like what column or what variable they should be attributed to. So I went ahead and did some correlation analysis and was looking at things mainly at what's causing cancellations, and right off the bat the default charge is very highly correlated, positively correlated with canceled, meaning that having a default charge of some sort may likely lead to a cancellation in a loan. And then, like, on the other hand, payments received here is very negatively correlated, so that means if payments are being received, it's likely they will not cancel a loan. So then I just did a heat map just to help visualize. Sometimes it's easier to pick out correlations like that. See, like, payments received, just a black square here, and this one's a little, more red than the others. It's just easy to pick out when you visualize it like that. I tried to do a cluster map, couldn't get it to work. Commented it out. So then, because I am looking to see what is causing cancellations, I saw default charge was highly correlated, so I sorted by the highest default charges and down and looked at the top ones, and you can see that over here in the canceled column, we end up running into a fair amount of ones, meaning that these loans did get canceled. So definitely want to be looking into the default charge variable. So I just listed them out. Everything looks normal. Just made a list of them. So then I went ahead and made a pie graph for it, and you can see the overwhelming majority of default charges are 0. So it's likely that you want to look in this section for cancellations. And I saw in the correlation analysis, borrower ID was kind of highly correlated with cancellations, so I thought that was weird and went ahead and looked at them, and they're just regular, they're just regular borrower IDs. There's nothing too interesting about it, and so I'm pretty sure that it's just redundant, and you don't actually need that column for the analysis. I went ahead and made some dummy variables. I didn't end up using them really, but I went ahead and just left it in there anyways. So then I start to get into the meat of my time series analysis, and I'm checking, the counts for each year. It increases each year, but since there was only 3 years, I decided I should look at the monthlies, and here is a much better graph. You can see that there's definitely some spikes going on, and I just also visualized it with a bar graph, and then I looking at the bar graph, I could see where a lot of these spikes are. It seemed to be March, so I then counted up for each month, and sure enough, March has the most accepted dates for loans. So it's likely you want to look in some of these higher value months. It's possible that the cancellations are happening more frequently in there. So then I do hypothesis testing on default charge to predict canceled. And I was trying to do some things, change the data types to get it to work. I could get statistic values, but I couldn't get my p-values quite correct. But since the company wasn't super interested in hypothesis testing, I just moved on. Then classification analysis. I made my test variables and tried to run it through a decision tree classifier and fit it to the model, but I was running into type errors, and that's why I was kind of trying to change them as well in the hypothesis testing, but it never ended up quite working, so I just moved on and did regression analysis, and I dropped this column. The instructions told me to. Just look at the head just to make sure that it dropped the column. And then I went to predict premium, and in the correlation analysis, down was highly correlated with premium. So I create a model using those two variables and end up getting these values, which can be turned into an equation. So if you're predicting with this model, you can put numbers into this equation. And I ended up with an R-square value very close to 65% accuracy. So I made a second model just to do it with this fin charge, I think final charge variable, and the model was not even close to as good as the first one. So you would definitely use the first model if you were going to use a regression analysis. And then I went ahead and did my clustering analysis to find the best K value for predicting. And so I went ahead and made a fresh data set with just a couple of the variables that were important to predict cancellation, and made a quick chart. And based on the chart, you can see that it drastically increases from 1 to 3, and then after that it tapers off. So that means the best K value is likely 3. So I made another quick graph, and you can see the intercept point is just between 3 and 4. So the best K values when using clustering analysis, you would want to use 3 for these models. Thank you for listening.